deals with the asymptotic notation, right? The first unit tells about the like asymptotic notation or the mathematical notation of the different types of complexities while you are analyzing the algorithm, right? So this first unit deals about the analysis of algorithm. So what are the asymptotic notation? Asymptotic is nothing but a mathematical notation. Okay, so as you can see from the slide, it is a, let me use the pointer. I hope my voice is audible for everyone. I'm like there is no any lagging, I think so. So that's where I'm proceeding. If any glitches, please let me know. Okay, I hope there won't be any glitches in this conversation. When you take notation, we have big O, big omega, and theta, right? These are the basic required notation for the telling the analysis of defining the complexities of algorithm. Apart from this, big O, big omega, big theta. Here actually it should be big theta. In syllabus they didn't mention here. Actually it is a big theta. Okay, big theta. And in case of little o, I have discussed about this little o, also little o and little omega. We will see what are the things there. Before getting into this, why we are studying data structure? Can anyone unmute yourself and tell what is data structure? I will give the provision to unmute yourself now. Yeah, I have give the provision to unmute yourself so that anyone can unmute and come out with what is the definition of data structure. Yeah, anyone? Guys, can you hear me what I'm speaking? Guys, at least reply in the chat box. You can receive my audio, right? Yes, okay, then anyone. Okay. So let me tell what is data structure. Yes, let me tell what is data structure. No one is replying, no issues. Data structures is what we are going to organize the data. That is what the main theme of data structure. You have like a huge voluminous of data, huge amount of data. Okay, like in terms of today, have enough number of data. Like big data, you might have heard the buzzword big data, right? One has chatting. Collection and arrangement of data in memory in sequential order. Yes, not only in sequential order, it cannot be such a way that it should be only in sequential order. It can be in some way, like wherever the memory is free, it can be allocated, right? That is what you said is right, but it can be accessed quickly wherever it can be, no issues. But there should be some proper algorithm, as well as the time complexity should be less when you are accessing the data from the database. Here I am dealing with the database. Database is nothing but, you heard the word database, where your data is going to be stored. Okay, that is database. You will study a subject called database, DBMS, right, after this semester. And data structure is what organizing the data, right? Hope you understand the difference between these two, right? Yeah, one of the guys replied, enough replying, thank you. It is specialized format of organizing, processing, retrieving, and storing data. Yes, very good. So here specialized format is nothing but your data structures coming into the role. What are the ADT? You are selling a specialized format, no? Stack, queue, tree, graph. All these are the specialized format you are saying. Okay, they have their own method to store the data. They have their own method to delete the data or access the data, whatever the case. Yes. So what data structure? Organizing the data in an efficient way. That's it. So once again we'll see about this. Okay, again these are the things you have seen. We'll give a quick wrap. I don't want to bore anyone. Okay, why? Because you have seen all these topics elaborately. I'll just go through it. Any doubt you can ask me, no issues. This is what data structures of storing the data in a computer so that can be used efficiently, right? Allow the most efficient algorithm to be used. Yes, to be used. And classification, again, this is important. When you say data structure, okay, you have studied this in C programming, primitive data type, right? That is what simple data type, okay, basic data type or built-in data type, whatever you can call, whatever word you can call, all those things: primitive, basic, simple, built-in. All. My voice is lagging, is it so, guys? Can you hear me, please? Give a quick reply bar. Instead of yes, it's like audible, clear.
Yes,
That
sir.
okay. Now can you hear me? Audible, yeah. Okay, thank you. Right, sometimes. Okay, I'll check this. Now can you hear me? Is it good? Now can you hear me, guys? I hope this now will be very much clear. Yes, okay. Don't waste the time. So we'll go ahead. So simple data structures, right? Simple data structure, compound data structure. Here, compound data structure nothing but what? A combination of more than one data type. More than one data type. One or like two or many are called compound data structure. That is okay, fine. And what are the types coming under this compound data structure? Linear, non-linear. Okay, linear data structure, non-linear data structures. So examples: stack, queue, list. See, this thing you have to remember for very much. You have to remember on this. You have to know the difference between linear data structure. What are the questions can be asked? That way you have to study. What are the possible questions? Descriptive questions only this time. Okay, you will all face the examination offline only. So, what are the questions? Maybe in the question asked, preferable questions. Difference between linear and non-linear. Examples of these data structures. Okay. Then what is the asymptotic notation? Okay, you have to tell about all these things. If they ask in 5 mark or 6 mark, discuss about asymptotic notation. Then you have to start writing, starting with the complexity. You have to tell about the complexity. Then two types of complexity: time complexity, space complexity. Okay, then how you are going to represent this complexity? There comes the picture of asymptotic notation. Okay, here comes the asymptotic notation comes there. Then and what are the three types? Big O, big omega, big theta. Then their representation, how order of theta you represent format. Okay, if possible, give an example for this complexities. Take some particular stack algorithm and tell this is the worst case of this algorithm. This is the best case of the algorithm. This is the additional added advantage where you can get score marks. Okay, these are the way you can highlight yourself to score the marks. It means that okay, this guy has studied something. He knows. So your presentation should be good. That is what they will expect. Okay, instead of asking discuss about means you have to tell all these things, and you should not take much time also, right? Keep on whatever the things you know, you should not keep on writing on those things only, taking more than half an hour or 40 minutes to spend for only 5 marks. Okay, that's not good. Okay, so you have to describe like that, discuss in this way. Then this is what again theoretical part. Okay, before it was uh, like a kind of tree structure. It was a theoretical part. What is simple, compound, okay, and linear. The contiguous arrangement. Contiguous means what you said, sequential arrangement. Okay. Even though, for example, if we say like let me go through the um, For example, you are having I want to allocate array of size, not array. I'm telling about some 5 MB of data should be allocated. 5 MB of data should be allocated, right? You know that this is example. You take this is an memory. Okay, each cell carries 1 MB. Okay, each cell carries 1 MB, takes 1 MB, and if you know that every what space has its own address, that you know, you have studied the concept called pointer. Do you want to tell about the pointer? No. If anyone requires pointer, I can explain now pointer. If anyone requires a pointer concept.
Yes, sir.
Okay, so it will be very much useful. Why? Because hereafter, like in case of a structure node, you might have used yesterday also, struct node star, something might have used. Yes, I don't know. You are using array. Yesterday, how you executed the program? Can anyone stack using array or a stack using linked list? Have you used any pointer concept in yesterday's program? Have you used any pointer concept in the yesterday's program? Okay, one guy is replied. Okay, array. Okay, yesterday we used only array. So it means that there is no pointer concept. Okay. So point is very important. So what will I do? For example, int a. Okay, int a equal to 5. That you know. It means that 5 is allocated in the variable a. What I am doing, int uh, int star b. Okay, it means that what b I can star b represents b is a pointer variable. What is a pointer? B is an integer pointer variable. That is what important here. B is an integer pointer variable where it can store the address of the its own data type, that you know. So b equal to ampersand a. So this is what is meaning. For example, I am declaring another variable, character variable, a equal to x. Okay, a equal to x. Then what I am doing, int star c. C equal to ampersand what a. I am declaring, let it be as z. Okay, avoid confusion. I am using z. So this is right. Okay, this is wrong. Why? Because C is what? Integer pointer variable, but it's storing the address of the what? Character variable. So it is wrong. This will not work. Okay, according to the protocol of the programming language. Okay, it will not work. So instead of that, they declare a void pointer. Okay, so void pointer is the pointer where it can store any type of data type. So any type of any data type's address. Okay, it's a generic pointer. V equal to, now it is possible, V equal to ampersand B is also what A is also possible, right? V equal to ampersand Z is also possible. Okay, why? Because it's a void pointer, it is a generic pointer, it can hold any type of others data type address. Okay, fine. This is about small intro of pointer, right? Next we'll see that structure pointer. To nodes or before getting to this, let me tell about this linear and non-linear. So here I told, for example, whatever the shaded one is allocated, memory is allocated. For example, I'm shading here some cells. It means that it is allocated. The memory is allocated. The free spaces are starting from array memory starting space address 0, 1, 2. With the free spaces are 0, 2, then what? 4, sorry, 3, 3, 4, 5, 6, 7, and 8. These are the free spaces right now in this memory. Okay. Now I want to store 5 elements. I want to store 5 elements. See, I represent. It's not array. Let it be like I want to store some 5 elements. How can I store here? There is no contiguous memory here, right? There's no contiguous memory. I cannot store here 5, but there is a possible first one. But there is what? There is 5 memory spaces there to allocate the 5 MB of data. Okay, but it is not contiguous in this memory. So what will I do? I'll make a link between the empty spaces. So I'll make a link between 0 and 2, then 2 and 3. I hope this is 3, you know. So here there are 0 to 8. This is 8. This is 7. You can understand. So I'm making a link over here. Right? So even though there is no space, but I am trying to make a link between the elements so that I can able to efficiently. So this is what I'm efficiently using the memory. So using the concept called linked list that we study. Linked list. Okay, this is another concept, linked list. This is how you link with the one. So I can now tell each and every empty space as a node. Okay, that will come node. What is node? What actually is node? I will tell. For example, you have studied. You might have executed a previous semester structure, a program on structure data type, right? You might have used some book or some personal details. Okay, if you want to store what book information, what data type can I use? Can anyone tell me? If you want to store book, if you want to store the book data type, I can use what? Structured data type, right? It means that you are using book. I'm telling about the book is what? Character. Okay, character array. Not a book, you will say it is a character array. Okay, but book consists of what? Book name, who is the author of the book, number of pages in the book, what is the price of the book. I can tell about n number of attributes of the book. Okay, for simplicity, what will take the number of pages. For simplicity, we will take number of pages in the book. Then the author name. Okay, so now I am telling this is a book data type, structure data type. I cannot represent these two in this in a one single data type, right? I need different data type. I can say this is a compound data structure, or user defined data type in your programming language. You say this is a user defined data type. You are defining your own data type. What the book actually should consist of. If you want, I can add a what int price also. It's like that. I can keep on adding. So I am molding I am defining my own data type. I am defining what should be there in the data type. So that is what user defined data type. Here the data type name structure name is book. And if you want to create an variable for the book, what you will do? See, this is what integer is a. So int is a data type. Okay, I am creating a variable a. Character is a data type. I am creating a variable z. Okay, as like this, book is a data type. That's all. Okay, you don't know what about integer, right? Okay, we are telling only int a. Int a is nothing but all these implementation, how it is working, integer or character, how it is working, how the compiler takes, all are defined inbuilt. We are only just displaying int character. We don't know how it is implemented. how it is interpreted also we don't know. That is what abstract concept, abstraction, right? Abstract data type. You know only what the abstraction. You know only the basic details. Integer is a data. It can hold some numbers. Character, it can hold some alphabets. Like that only you know. How it is interpreted, character, how it is working, all are defined inside the header files, right? That you don't know. We know, for example, if we go to, if you get into log into the internet banking, if you log into internet banking, what you will do? You will just want to transfer some amount to other person, 1,000 rupees. Okay, you are doing some transaction. Your amount is debited. That's all. That's all you know. How it is implemented, you don't know, right? You have that privileges only. That is what abstraction. So just an example of abstraction is meaning that it does not tell the how it is implemented. Okay, how it is implemented, or I can say this one. I can say this one. I'm using the in add. Okay, so this is an example of abstraction. Function prototype. I can tell from this function, it is an add function. Okay, it add two numbers, that's all. It taking two argument. Okay, and it returns integer data type. Instead of, you might have seen as this also. I don't want to much into get in that. Most of them are very clear in this all those things. Okay, so it means that this add function takes two integer, two argument, doing some operation, but it's not returning anything. That is not void. Guys, are you following? Guys, can you reply? Give a quick reply. This is what the abstraction. Yes. Okay. Thank you, Pa. So this is in terms of function. I'm telling about this function. I can tell this is a what is also ADT, abstract data type. It tells only what is there in the book data type. Price, number of pages, author name is there. That's all. Okay. It tells only what? It tells only character. Okay, something is there. It is storing some alphabets. That's all you know. You don't know about the implementation. That is what abstraction here. That's what that comes the name abstract data type. Okay, fine. So here this one I thought to tell. You are making a linked list between the nodes. I can say this is a node. Now instead of cell, I can say each and every space as a node where it is going to store some information. Okay, each and every is a node, right? So I want to create a what? I want to create a variable for this. What you will do? Book B1. That's what you are doing. Now, for example, I'm making here. This is one. How will you access the? I want to print now price of the book. What you will do? Printf. I'm not writing the full syntax. Just B1 dot price. That's all you will do. I'm not writing the full syntax. I'm not writing any percentage D or something else. Just for understanding purpose, I'm simply writing. Okay, B1 price. That is fine. If you want to print number of pages, B1 dot number of pages. B1 dot author name. Okay. For example, in addition to this, not able to erase this 1 second. One second, Pa. 1 second, a minute. I want to add some this to this. Let me create another better. Quickly, I create another one. So it will data, and in now I am creating what I am creating pointer variable in the book structure. Okay, now you can find the difference between this right side and this left side. Right side consists of what? Only the primitive variables, only the like not primitive, only the basic normal variables, integer. There's no pointer variables. But in the left part, you can find what pointer variable, integer pointer variable. How will you access this pointer variable? Can anyone just type in the chat box? How will they access the? See, this one you will access b. Okay, I'm creating a book variable. Even you can create here that you know. I can also create b1 here. Okay, fine. I created here b1 dot data. Okay, fine. Now, how will I access the variable I? Can I access like this b1 dot I? Is it right? You know all these things. Come on, guys. Using which operator you will access the pointer variable of the structured data type? Since it is a discussion class, you can discuss with me at ARR. ARR means ARR array. You know, right? You know, I think so. You can speak out at least. You can unmute yourself and you can speak out. And no, and also will not come up. No, and is not used to access this one. I'm getting more replies. Star, no, array, no. I'll tell you. See, here you will use what? Arrow operator. I hope this is visible. And otherwise, I'll make it somewhat bigger. Here. I want to access the pointer variable in the structured data type. So what operator I'm using here? This is dot operator. Even dot is an operator, right? B1 dot. So what operator you are using to access the pointer variable? Arrow operator. Arrow operator, how will you put? Just put on a hyphen and greater than symbol. Okay. This is what accessing the pointer variable. This one I want to tell here. This only will be frequently using in your programming. Starting from when you say linked list. When I say linked list, okay, it means that what? I want to link a node between another node. How will you link with the other node? How will you connect with your another friend? How will you go to another friend's house? If you know the address only, you go to the another friend's house, right? Okay, so you should know the address of the next house. Okay, right? That is what. So I want to access the next node. So I require address. Then where you will store the address? In what? Pointer variable only, right? So you will be frequently using these things. I hope this is understand. Yeah. Next, we'll go to the slide. Do you have any doubt in this part? Do you have any doubt in this? No, sir. Okay, thank you. Okay, this is what non-linear data structure can be constructed as a collection of randomly distributed set of data items. See, I told no. Now linked list can be considered as a what? Non-linear data structure. Okay. It will be considered as what? The linked as well as non-linear as well as non-linear. Here, but generally the graphs, tree data structures will come under the category of this type. Non-linear data structure is a collection of randomly. That's what you told in the when you want to allocate 5 MB of data, okay, but you cannot allocate contiguously, right? Sequentially. Why? Because there is no space in the memory. But instead, what you are doing, you are trying to make a link between the nodes. It means that the nodes, the spaces are distributed. It's somewhere else. It is random. You are trying to connect the each and every node. So you are forming a particular structure and joined together by using a special pointer. Okay, right? So this is what non-linear data structure and linear data structure. Here, this one you can find in linear data structure. The relationship of adjacency is maintained between the data elements. Yes, because if it is like array, for example, array is a linear data structure. Okay, the relationship between each and every element, between the elements, the relationship between the elements is based upon the data elements only, right? With the index, I can just directly increment the index value, then I'll access the next data. Then if I increase this one, I'll access this one. Okay, like this. But here, in case of relationship of adjacency, is not maintained between the data items. Yes, it is based upon the pointer where you are storing the address of the next node. Okay. So again, operations on data structure. Yesterday also you have done push pop. Yesterday, in case of stack, there is a naming convention. Instead of add, you told push. Instead of delete, you told pop. Some name only differs. That's all. But the operation is not same only. When you take Q, okay. When you take Q, what? NQ, DQ. I think someone wants to speak. Roshan Kumar, you want to speak out, Pa? You have unmuted yourself. Let me have some water. Wait for a couple of seconds. Okay, just wait for a second. I'll have some water and come, please. A couple of seconds. I'll mute myself, guys. I'll mute myself for a couple of seconds. Okay, guys. Let me start resume the class. Okay, these are the operations. Okay, when you take Q data, NQ is nothing but ENQUE. NQ is nothing but you are adding the element into the queue. DQ, deleting element, all are same. Only the naming convention depends upon the different data structures. Okay, this is all very much clearly we have seen ADT, right? Providing only the level of abstraction. Okay, so it means that you have studied what object-oriented programming. You might have studied object-oriented programming. There come concept called one of the OOPS concepts, encapsulation. It means that you are hiding the detail. That is what this meaning. Only the abstract level is seen. They are hiding the implementation. It is one of the big advantage of the OOPS concept. OOPS programming language, OOPS programming language, object-oriented programming language. Encapsulation, one of the major concept. Only the private informations are not revealed. Okay, and algorithm. Okay, of instruction. Okay. And there's some history on the algorithm. This and all we have seen, and algorithm steps. Okay, then properties of the algorithm. It has to what satisfy these properties. It should satisfy these properties. If it means that it is an efficient algorithm. It should be generality. It should solve all the problems of a particular class. You have to develop an algorithm like such a way that it has to solve any number of problem under the same class. A particular area you are choosing, particular research you are choosing. For particular research, your algorithm should solve all the problems, right? That it should be in such a way that your design algorithm. Yes. Next is and then algorithm. This is what we told: algorithm, analysis, and complexity. Time and space. We told time, space. You know about time and space. Then these are the basic theories: empirical or posterior testing. All these things you go through it. Then this one I don't. This one is very much important. We discuss big O, upper bound, right? And upper bound is nothing but what worst case, best case, and average case. We have told about the amortized analysis also, right? Amortized runtime complexity. Okay. So all this worst case, best case, you have to remember in this unit. What is little also we told, right? So big O is nothing but tight. Keep it in mind. Upper bound. Tight upper bound. When you take this one, see, this is tight. Sorry, tight upper bound. Generally, we won't tell us tight. Okay, tight upper bound. Okay. Complementary to this little O, little is nothing but loose upper bound. It should not be always like 10 seconds. Worst case is not 10 seconds. It can be 9 seconds. Can be 8 seconds also. So in order to mention like that, they have used another notation called little. Okay, little O and little omega. Okay, this also we have discussed very much clearly. Then constant time is very much important. Constant time. You are going to analyze the algorithm based upon this computational time. Right? I have told many times about this constant time. Nothing but if I, for example, I am taking attendance in your class. I am taking attendance in your class. I'll use USN. Right? If I tell 99, suddenly that person 99 is responding. 88 person is responding. So it takes only constant time to get to do my operation. Whatever may be the operation. Okay. Whatever. So it takes only constant time. But linear time, right? I drawn this graph based upon the input. It takes time. Based upon the input, it takes time. For 5 peoples, okay, 5 seconds it will take. For 10 seconds, sorry, 10 peoples, it will take 10 seconds, like that. Okay. So it depends upon the input size, the time varies. So it was linear. It is proportional to the what input. So here it's already directly proportional. Here it is written. Yes. And as like that, you have logarithmic time. What is logarithmic time? Can anyone explain what is log n? Can anyone explain? Hope you have studied the mathematics in the schooling also. What is log n? How will you represent log n?
One.
What pa? You can speak out. Log n. See, if I tell n, order of n, I'm telling order of n depends upon n is 5 means I say the output time is 5. If our input is 10, output time is 10, like that. Here I'm not telling about this any example, like how it is working. For example, log 1000. What is answer for this? 10 cube, right? 10 cube you can write, so 3. Okay. So here this n can be number of digits. For example, 5 digits is there. Okay, how can you write log 2, 3, 5, 7, 1, and this is 1 point.
No.
So here what 1, 2, 3, 4, 5 log n is here 2, 3, 5, 7, 1. So what is the answer for this? Okay, the answer will be how many number of digits. How many number of digits is the answer? Okay, hope you can work it out as a homework. Just or not a homework, just go to the internet. So based on the number of digits, if the n is number of digits 5, the output will be in 5. Okay, if the number of digits is 10, the output will be in terms of 10, like that. Just go through it, take it as a homework, and just surf the internet. And the quadratic time, it is 5 square. The output is 25. That's it. So like that, you have several other also complexities also there. Okay. Then this one we are seeing like example of worst case and best case. This binary tree. This you can study in the 4th or 5th unit. I don't know. You come in the 4th unit. So right now we don't want to get much confused in this. If you want to remove the slide also, no problem. Instead, you can take the sorting techniques. You have seen the sorting techniques. No, some sorting techniques that you can take it. Okay. And tell about the analysis of algorithm. Okay. Tree concept is new for everyone. So what you can do, you can ignore this slide, no problem. So again, this and all basic things. How the time computational complexity is calculated, right? So this one it takes what? Only 1 second. Frequency count. It occurs only one time in this line of code. Occurs only one. So it means that it takes only one. The complexity of the program segment is order of 1. Like that. See here, what is here? Nothing but order of n. How we are telling is order of n? I told in the class also. Depends upon the degree of the algebraic equation. Depends upon the expression, degree of the expression. For example, I told 3x square plus 5x plus 2. So the degree is what?
2.
So I can say that this algorithm falls under the category of n square. Got it? See here, 3n plus 1. So the higher degree is n power 1. So that's what I'm telling, order of n. It means not that, like for example, if I'm giving a 5 input size, it is not only 5. It should not only 5. It can be like this. 3 into 5, how much? 3 5 are 15 plus 16, right? So if I give 5, the answer is 16 for this. Right? But order of the complexity is what? Order of n. This depends upon the degree. We are telling the complexity. Fine. So you can go through this. Why this is n plus 1? Number of times it is executing. Right? I mean n plus 1. That is one number. Number of input plus 1 taking extra time. It is iterating. Okay. So all these things, just nothing is big thing here. Don't want to much get deep into this also. Don't worry if it is like just see this. It is for an example only. It is given. Okay, I can say this is an order of n square. That's it. Don't make much get complicated yourself. Okay, don't get complicated. See, I can tell how it is coming in order of n cube. Depends upon the equation. Depends on the degree of the equation. Yeah. Fine. Asymptotic notation. So here tells up each and every slide tells about the big O, nothing but upper bound of the function. Okay, and omega, upper lower bound of the function. Then theta is average case. Okay, fine. So this also you might know what is this, nothing but n factorial. There may be some algorithm will take what n factorial time to execute the operation. Okay, so these are all things you have to remember. Nothing, no other go. In this first unit, you have to study all these things. What is linear time? What is quadratic time? You should be they asking 10 mark. You have to write all these things. They'll give sure they'll give the marks. Okay. First you have to understand what is that, what is log n, what is order of n square. So different time complexities. Okay. And I don't discuss about iterative and recursive also. There's a difference between iterative and recursive, right? First example, you can take even in our syllabus, they are told about analysis of iterative and recursive. So there may be question on this also, a big question on this also. Okay, what is iterative? What is recursive? With an example, right? You can use for loop for iterative, and what recursive function you can use what? It's a tower of I. Okay, factorial. All these things you can use Fibonacci. The searching methods, basic search. Why here they use searching method is because to analyze the algorithm only they used. Searching are two types. Mainly we always consider only two types. We don't tell about the Fibonacci search. Okay, linear binary. There are other searches also. Exploitation search is there, and exploitation another one something is there, and I can't able to remember. There are major searching techniques are there, 4 to 5 techniques, but usually we'll say linear and binary search. Even that also I think you experienced the previous semester. The noise is there. I'll mute myself for a second. I'll mute myself. External noise. Okay. Yeah. Thank you. Thank you for your patience. So this what we'll say linear search and binary search. Why? Because which is the best one? Always will prefer binary search. Always will prefer binary search. We don't prefer linear search. Okay. Why? Because linear search will what will do? Linear search will uh, start searching from the each and every element, starting from 0th index to n minus 1 index. It will keep on searching. If the searching element is at the last index, for example 6 is here. Okay, you want to search element 6. What you will do? Keep on starting from 0, keep on goes, and finally you will find. At last only you will find. If it is like what 1000 elements are there, and your searching element is at the last, it takes 1000 seconds, right? So it is a drawback of the linear. There we'll go for binary search, right? Binary search is nothing but we're dividing the first I will divide this 1000 to 2, 500, 500. Okay, like that. So that's why we are saying it is in log n. It takes log n or n log n, I don't know. We'll confirm that. So binary search algorithm takes log n time to search an element. It takes logarithm time. Linear search. So another 5 minutes we'll have. We'll just wrap this section. That's what. And bubble yeah, sorting techniques you have seen. Bubble sorting, right? How it works? Like you are making the largest element in the what array to what make into the bringing into the last part of the array. You will try to make the, see, for example, I'll draw here. See, this is an array. Okay, having element 10 here, 3, 5, 7, 9, 8. This is the given elements in the array. Here, which is the element 10, biggest element 10. I mean, right now, for example, what you will do, you will try to bring this largest element towards the right when you are trying to sort in the ascending order. If you want to sort this element in the ascending order, what you will do, bring the largest element towards the right end of the array, like that 9. You will try to bring it to the right end. That's what bubble. How the bubbles work? It flies, right, like that. So you can think on this way, and that how the algorithm works. And passes are nothing but number of steps. Okay. I have only taken this insertion. Your example, playing cards. Okay, try to remember the playing cards. It's a simple algorithm. Insertion is a simple algorithm, but it takes more time. Yeah. Thus, the average case also have a quadratic running time. See, even the average case also it takes quadratic running time. And merge sort, we have seen it follows the divide and conquer. Your merge sort and quick sort follows the divide conquer method strategy. Okay, all these things you can tell. Quick sort, yeah, quick sort. I told pivot element. Can you remove the pivot element part? Can you guys, are you clear with the quick sort? Can anyone reply? I have teach this pivot element, quick sort in the day before yesterday's class. Can you remember? Yes. Okay. Thank you. Yes. One thing I will tell here. See, at this position, I want to convey this alone. See, at one stage, what is the pivot element of this array? 27. 27 is the pivot element. What we have chosen. Okay, pivot element is chosen based upon you only. You can choose either 27 or 45, but you should not change. Okay, so 27 is a pivot element. At one stage, what happens after doing your applying the algorithm? The 27 will come into one position. It means that all the right, pivot, and left will point to the same index. It means that you have to stop the algorithm. It means that the whole algorithm is not stopped. You have done only the one pass. You have done one pass. You have completed one pass. So here you have to take the left subarray. Okay, and you have to divide. Now you are dividing. This is the right subarray. Okay, now I will take what 25 as the pivot element. So 27 is over. It has come to the right position. How I say it's the right position? Because the left part towards the left part of the 27 is lesser than the 27. Right part of the 27 is greater. So I tell that 27 has come to the right position. Okay, there I stop the first pass. I'm stopping the first pass. Okay, I'm going to start the second pass. What is the second pass? This one. This will go parallelly and this will go parallel in the second pass. Now I choose 25. This one I have to say. Now I'll choose 25 as the pivot element. Okay, then it will come to one position. Anyhow, it will be at one stage. What happens? 10, 18. Okay. Someone is unmuted. You want to speak? Manideep, Beverly City. Manideep. Okay. So 10, it will come like this only. After applying the algorithm, after doing the pivot operations, all those things, it will be in this order: 10, 18, 25. So it means that 25 as is come to its correct position. The left part are lesser than this 25, but right part you don't have. It is the last element, so you don't need to worry. Again, I have to do Again, I have to take only 10 and 18. I'll apply the algorithm for this. Then it will be 18, 10 will come. 10, if I take the 10 as the pivot element, it will come to the right position. Here the same position will fall. Why? Because it is lesser than this element. So it will come to the right position. Stop annotating, please. I can able to disable also, and we can track those who are annotating also. We have the option in Zoom settings. Okay, so please don't do that and make yourself what I can say. Right? So this way, we are keep on doing the operation. At one stage, what happens? Everything will be sorted. It will be coming like 10, 18, 25, and 27 in the right position. 36 will be sorted after doing the applying algorithm. It will come like this. Right? So now it isn't sorted out. 27 will come. So this is how the quicksort works. You can see the video also. The complexities, and this one you have to by heart it, at least you have to by heart it. Okay, what is the sorting time complexities? Abstract type, that was told. This is the abstract type, major abstract type. Shall we close the class, guys? Guys, shall we close the class?
Yes, sir.
Yes. Okay. Okay. Thank you. Thank you. Is it first one is